Hello everyone, it's Momo Kell. You're welcome to this page. Thanks for watching the video. I hope you like it to the end. So here we're dealing with sequences and series. This is the scheme one we're going to follow throughout our learning video. So we start with definition. What is sequences and series? So it is said to be a basic topic in arithmetic, very similar to set, but with the main difference that in a sequence, individual terms may repeatedly occur in various positions. So now let's look at the difference between a sequence and a series. So a sequence is said to be an orderly arrangement of terms having a rule for obtaining the preceding term. For example, you're given this arrangement of terms. It can be called a sequence because it is orderly arranged, that is in ascending order, and it has a rule for obtaining the preceding term. Here you can see that from 3 to 5 there is an addition of 2, and from 5 to 7 there is also an addition of 2. Therefore, the rule for obtaining the preceding term is by adding a number of 2. You can also be given this arrangement of numbers, maybe. It can also be called a sequence because it is arranged orderly in descending order, and it has a rule for obtaining the next term, which is by adding -2 to each term for having the next term. So those are examples of sequences. While when we talk of a series, we mean summation. We mainly think of summation. If maybe we are asked the series of this sequence, then we are going to say it is 7 plus 5 plus 3 plus ... So when we talk of series, we simply mean summation. So now let's go to looking at the general term. So this general term is mainly called nth term. It is a term or an expression from which any other term of a sequence can be obtained. That is, if we are given this term and we are asked to find terms of a sequence, then we can just replace the term we are looking for into the n we are going to have in the expression, and we have the term. So if you might be you are given this sequence, take for example, you are given this sequence and asked to look for the general term of the sequence. That is the term from which you're going to have might be the fourth sequence, the fourth term in this sequence. So to do that, you establish a one-to-one correspondence with the set of natural numbers. The set of natural numbers, which can be 1, 2, 3, till the n number, depending on the number of terms we have in the sequence. Then if we establish the one-to-one correspondence, we can have nt standing for the number of terms, which is represented by the natural numbers. And then we have the terms, the corresponding terms, which is 3, 5, and 7. Now, we write 5 in a way that 3 can appear, which can be 3 plus 2. We do same for 7 here. It can be 3 plus 4. Now, we look for a way that these terms, these other terms can have coefficients. That is, we put it in a multiplicative way. So we are going to have 3 plus 2 into 1, which comes back to this, and 3 plus 2 into 2, which comes back to this. Now we are going to change our coefficients, which are 1 and 2, into, we are going to put it in the form of the number, the natural number corresponding to it minus 1. The natural number corresponding to it minus 1. So we are going to have this 3 plus 2 into 2 minus 1, 3 plus 2 into 3 minus 1, ... we relate it to the n, 2 into n minus 1. And this is said to be our n term or our general term, since it contains the number we are looking for. The n. N stands for any number, for the number we are looking for the term we are looking for. So this is said to be our general term. Okay, so now that we know our definition, we know the difference between a sequence and a series, we know about the general term. Now let's look about the types of progression of a sequence. A sequence can be in many types of progression. It can be in an arithmetic progression, it can be in a geometric progression. There are other types, but we are focusing on these two types. So let's first of all take arithmetic progression, which can be denoted as AP. So let's define it. So a sequence is said to be in an arithmetic progression if and only if between the terms there is a constant number, that is, moving from one term to another, there is a difference of a number or an addition of a constant number. For example, take this sequence. If you are maybe asked to prove that this is an AP or show that it is an AP, we're just going to look at the sequence very carefully and observe whether there is not a number, a common number between the terms that is moving from the first term to the second term. Here we see that moving from the first term to the second term, there is an addition of 2. Moving from the second term to the third term, there is still an addition of 2, meaning that 2 is constant between the individual terms. Therefore, it is an AP. That 2 can be called the common difference. This common difference, denoted as D, is the number which proves that a sequence is in an arithmetic progression. Meaning there is a constant number between the individual terms. This D is given as the second term minus the first term, which should also be equal to the third term minus the second term, or the fourth term minus the third term. It continues and so on, so forth. So for example, if we are asked to find for the common difference, look for the common difference of this sequence, we are just simply going to do 5 minus 3 or 7 minus 5. We're still coming to the same answer. So now let's move to what we call the n term of an arithmetic progression. So when we talk of n term, it is usually denoted by UN or Tn. So when we talk of n term, UN or Tn, n term of an arithmetic progression, UN or Tn can come to our mind. It is very similar to the general term we have previously seen. It is very, very common. That is, the way of finding it is very common. We still establish a one-to-one correspondence between the arithmetic progression and the set of natural numbers. So let's see. How do we get our AP? So given that the first term of the AP is denoted by A and our common difference D, then we should know that the second term is given by the first term plus the common difference, which is A plus D. The third term is given by the second term plus the common difference, which is A plus D plus D, and so on so forth. The third term, the fourth term is equal to the third term plus the common difference, which continues so on. So if we have A plus D and A plus 2D, so on. So this is our arithmetic progression. Now we establish the one-to-one correspondence with our natural numbers, which is 1, 2, 3 to the n number. Here it corresponds to A plus D and A plus 2D. Now we do the same for the general term. We make the coefficient of D to become the natural number minus 1, which gives A plus 2 minus 1D, A plus 3 minus 1D, and also A plus n minus 1D. And this is said to be our nth term. Therefore, our un will be equal to A plus n minus 1D. So from this expression, you can have any term of an arithmetic progression. If you take, for example, you are given this arithmetic progression, 3, 5, 7, 9, and you are maybe asked to look for the fifth term of this arithmetic progression. You just have to substitute our values into our formula. That is the first term. Here we are looking for the fifth term, that is U5, which will be equal to A, which is the first term, 3, plus N, which is still our 5 minus 1, and D, which is 5 minus 3, still the same as 7 minus 5, and 9 minus 7, which is 2. Therefore, our fifth term will be 3 plus 4 times 2, 8, which is 11. That is our fifth term. And we can even look for the 20th term or the 100th term, because we don't know where this series ends, because it is an infinite sequence. Now that we know about our nth term, let's look at arithmetic mean. We know about the definition of an AP, the common difference, the nth term. Now let's look at the arithmetic mean in an AP. That is, if we are given 3 consecutive terms, x, y, and z. If we are given these 3 consecutive terms, when I say consecutive terms, it means that they have a common difference. If they are consecutive, therefore they must have a common difference. Let's see. We know our formula of common difference is second term minus first term, which should be equal to third term minus second term. And if we solve this equation, we have 2y, which is equal to x plus z. So that y will be equal to x plus z on 2. Therefore, y is said to be the arithmetic mean of x and z, or the average of x and z. Another name for arithmetic mean is average. So y here is said to be the average of x and z in this sequence. Now let's look at the sum of an AP. What is the sum of an AP? It is usually denoted by Sn. That is, it is the summation of a number of terms in an AP. It is the summation of a number of terms in an AP. For example, if you are given a sequence like 3, 5, 7, the sum of these terms will give us the sum of an AP. Since it is an AP, we will then call it the sum of an AP. It brings us back to a series. When we talk of series, we talk of summation. Therefore, if now you are asked to look for the series of an AP, just think about the sum of an AP. So if we have our AP to be A plus D, A plus 2D, and so on. This is our AP. Then the sum of this AP will be A plus D plus A plus 2D. We write it smaller, A plus 2D plus dot dot dot. We have this, our last term that we found was A plus n minus 1 D, n plus dot 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 plus A plus n minus 1 D. Now this will be called the sum of our AP. Okay, if we reverse it, if I write this in a reverse order, it will still come back to the same thing because it is addition, it is commutative. I can write it in any form. So if I write it in the reverse order, then I'm going to have A plus n minus 1. That is, I start from the last, moving backward, plus A plus n minus 2. This number will be adding, plus A plus n minus 3, plus dot 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 plus A. So we are looking, I'm doing this because we are looking for a formula for our Sn. We can't allow it to be this long. So we are looking for a way to give it a formula. So we can call this first equation 1 and the other 2. So now if I add the two equations, that is 1 plus 2, equation 1 plus equation 2, I will have Sn plus Sn, which is 2Sn, equals to A plus this, which will be A plus n minus 1, which will give me 2A plus n minus 1D. Plus, if I take this plus this, which is A plus D plus A plus, I open up this bracket, which will be nd minus 2d plus, I continue adding, you can continue adding it. You see that it gives you A plus A, which is 2A, D, let's say plus nd, and D minus 2D gives us minus D. So since this here D is common, you can then factor out and have n minus 1D. If you continue adding, you will see that you have this very answer. And therefore our 2Sn will be equals to n 2A plus n minus 1D. So why this n? This n is here because if we continue adding up this, we are going to have a number, a certain number, and that certain number multiplied by it will still give us this plus this plus this. So we just reduce it and just multiply it with the answer we have when we add it all. So you can't add continuously because it is infinite. We don't know where it ends. We just put n there. So now our Sn will finally be equals to n on 2 into 2A plus n minus 1d. So therefore this is the sum of our AP. Thanks for watching. Don't forget to like and subscribe to follow me on this page so that we are going to continue with geometric progression in our next video and solve some example. Thank you.